Good morning, everyone. First of all, I would like to thank the organizing committee for accepting my participation in the National Conference of Material Science and Engineering. So, I have the honor to present my work talking about very interesting subject titled Band Gap Engineering and Photocatalytic Enhancement in Zinc-Doped Copper Oxide Nanostructure for Water Treatment Application. Okay, we start with presentation plan. Firstly, we have introduction, second copper oxide, then characterization method, after discussion result, and the end conclusion. The scientific research and industrial development have opened a way of nanoscience and nanotechnology. In recent years, a number of studies are focused on nanomaterials, such as copper oxide, is used in several fields of application, gas sensor, photocatalysis application, and self-cleaning technique. At present, water pollution is a problem to environment, posing a threat to humans and living organisms, to the chemical pollution resulting from industrial wastes. This prompts us to find solution to it by using thin films of copper oxide N-doped and doped with zinc for photocatalysis application, as well as the degradation of orange to dye. It's present the most colored material used in industry, so it's the most polluted. In addition, is carcinogenic dye. Reason for choosing of copper oxide. Copper is multivalent metal that reacts with oxygen from two oxide phases, tenorite phase and copperite phase. In this work, we focused on tenorite phase of a monoclinic structure with group space C2C. This figure presents the structure of copper oxide. We choose copper oxide because it is used in many fields of application. No toxic, economic, and good adaptation to environment. In addition, is industrializable. Salt gel spin coating method. Thin films of copper oxide N-doped and doped with zinc were elaborated by salt gel spin coating method on glass substrate using precursor of acetate with element of doping dissolved in ethanol with a molarity of 0.2. In the end, we used calcination of our films at 400 degrees Celsius for 2 hours. The following figure presents the XRD spectra of copper oxide N-doped and doped with zinc. All films present the formation of tenorite phase of a monoclinic structure with group space C2C. After doping with zinc, there are a displacement of peak which represent the occupation of ion seat of copper by ions of zinc. According to XRD, we can calculate the crystallite size and microstrain by using the Williamson-Hall plot method. This figure presents the variation of microstrain and crystallite size as a function of doping rate with zinc, such as the crystallite size of our films varied between 21 nanometer to 53 nanometer, is increased with increase of doping. According to optical properties, we can determine the transmission spectra and gap energy. This figure presents the variation of transmission spectra as a function of wavelength. All films present an average transmission in the visible range. According to transmission result, we can calculate the gap energy using the torque relation and by plot the alpha h nu square as a function of energy photon. And by extrapolation method we get gap energy, such as the gap energy of our films varied between 2.62 electron volt and 2.35 electron volts. This figure presents the FT spectra. All films present the formation of copper and the oxygen band in the range of 400 to 900 cm-1. Principle of photocatalysis application. The hole in the valence band interacts with water to produce hydroxide radical, and the electron in the conduction band interact with the oxygen to produce superoxide radical. The superoxide radical interact with the hydrogen cation to produce dihydrogen water. So each hydrogen water interact with the photon to produce two hydroxide radical. The hydroxide radical interact with the dye and degradation with the product the water and carbon dioxide. The following figure presents the absorption spectra of orange to dye with the presence of films as a function of wavelength. All spectra present the degradation of orange to in the time between 1 hour to 5 hours. The maximum absorption in the wavelength is 485 nanometer, which represents the wavelength of orange 2. The following figure presents the speed of degradation of orange 2 with the presence of our films. It can be seen the degradation of orange 2 increase with addition of doping. Conclusion. Study effect of zinc doping copper oxide on structural, optical and catalysis properties is the aim of this work. According to XRD diffraction, all films present the formation of tenorite phase of a monoclinic structure with group space C2C, with the crystallite size variated between 21 nanometer to 53 nanometer. According to optical properties, the gap energy variated between 2.662 electron volt and 2.35 electron volt. The best degradation of day is represented in the thin films of copper oxide doped with zinc. Thank you for your attention.